Alright, let's take a look at these two problems here. We've got another set of problems where we're just multiplying, but in this case it's a fraction times a whole number, and sort of the same thing here. And again, we're doing this because I want you to see this side by side. Now, if you recall, when you multiply with fractions and you get a problem like this where it's a fraction times a whole number, it's actually easier if we work with nothing but fractions. So what we want to do is change 42 into a fraction, and the easiest way to do that is just to place it over 1. 42 divided by 1 is still 42. So later on, or you know what, in fact, why don't we do it now? Same thing applies over here. Instead of doing this binomial divided by this binomial times this trinomial, it'd be better if these were both written as rational expressions or fractions. So what I'm going to do is I'm going to take this trinomial, and just like I did over here, turn it into a fraction by just placing it over 1. Okay, so we'll get to that one later. Now over here, once again, what we do is we just do the same thing in the last problem. We think about what will cross cancel, but we actually show that work. So when I go through this, well, 13 is a prime number. That's not going to factor. But then I'm looking at the 12 and the 42, and I'm thinking to myself, yeah, you know, the greatest common factor that those two share would probably be 6. 6 goes into 12, and 6 goes into 42. So I can take 12, break it up into 6 times 2, and then 42 I can break it up into the factors of 6 times 7. And of course we've got our 1 down here. Now we can go through and cross cancel. In this case, not a lot cross cancels. Here we've got 6 and a 6, and that's basically it. 13's prime, 7's prime, 2's prime. So the best we can do here is just multiply all this back together, which is, let's see, 13 times 7 would be 91 over 2 times 1, which is 2. And I've already cross-canceled, so I know this won't reduce any further, so I can leave it like that, or if I wanted to, I could change it to a mixed number. Alright, so let's apply the same thing over here. Now, we've already done the first step. It's better if everything's written as a fraction, so we changed our polynomial here into s squared plus 5s plus 6 over 1. Now, let's see if we can't factor any of these pieces. So as you go through it, step by step, we just look at each individual part of this problem. So I'm looking here first. 3s plus 2. I run through all the different ways I can factor, and none of them apply. So I think this one's kind of like our 13. It's a prime number. So we're just going to leave it as 3s plus 2. Now, this piece on the bottom, this will factor. 2s and 4 have a common factor of 2. So I can break this down a little bit by undoing distributive property. Take out the 2, which would make the leftovers inside s plus 2. 2 times s is 2s, 2 times 2 is 4. And then over here, this trinomial I think will factor as well, because s squared was probably beforehand s times s, and with 5s and 6 I'm thinking the combination that's correct is 3 and 2, because 3 times 2 is 6, 3 times s is 3s, s times 2 is 2s, 3s plus 2s is 5s. And then again, of course, over 1. Now, it's at this point where I can cross things out, because once again, in order to cross things out and cross cancel, it has to be a factor. We have to be multiplying with it. So once I've got everything in parentheses like this as a multiplication problem, now I'm allowed to cancel things out. So in this case, just like this one, there wasn't a lot that would cross out. So here, s plus 2, s plus 2, and that's it. So what we're going to have to do is put this all back together. 3s plus 2 times s plus 3 over 2 times 1, which is 2. Now, sometimes they ask you to leave it in the factored form, which would be like this. But if they ask you to simplify it all the way, then what you would do is then multiply all this back together again. So, you know, whatever problems you're doing, read the instructions. If it asks you to leave it in factored form, you can probably stop right here. But if it asks you to simplify it all the way, then what we want to do is multiply this top part back together again. 3s times s is 3s squared. Let's see here, we've got 2 times s, which is 2s, 3s times 3, which is 9s, 2s and 9s is 11s, and 2 times 3 is 6. So we get that. Alright, so again, try to connect the similarities between what we used to do with fractions with what we're now doing with rational expressions.